Okay, well, now we've got that set up. Let's take a look at the spectrum. Here, I'm going to share the screen from the computer. Okay, there we are. So what you see here is something interesting. You see a sharp line, a larger sharp line that's at the laser frequency. And then there are a number of other smaller sharp lines with lower amplitude at longer wavelength. These come from the fluorescence of the iodine, whereas the first one is laser light that's scattered by the iodine molecules themselves. Here, let's rescale this, and then let's use a longer integration time so that we can get better signal to noise. Here, I'm going to play around with that. 1 second. Okay, this is much better. We can even do a little bit better by doing a trick. Some of the noise that a CCD camera, like the one we're using here, produces is what's called dark noise. And we can subtract it by taking a dark spectrum, taking a measurement where there's no laser light. So let's go ahead and do that. We'll give it a shot. I'm going to stop this. I'm going to pause. There we go. And now we'll record this as the dark spectrum. So this is with a spectrum taken with a laser light off, laser light block. Now when it's done with this, it should just show us the difference between the current spectrum and the dark spectrum. Okay, that looks good. Okay, and it's acquiring data now. It'll be done in a minute. It's averaging over 10 acquisitions at 2 seconds each acquisition, and should be done now. Okay, so you can see how nice and clean the data is at the moment. We'll pause once this is finished and then save the data. Great.